Okay, so now let's start again. Let me share again. Okay. Okay, so now what we are going to do is we're going to import this number library as NumPy. Now, what I want to do is I want to create a, say, an array. Okay, and then I can, this is an example of an array of 3 rows. This is the first row. I have 1, 2, 3. Second row, I have 4, 5, 6, a list of 4, 5, 6. And this one, 7, 8, 9. What does it do? If you print it, it will create something like this. This is actually a matrix. Let me copy this, and then let me put it in the chat section so you can copy and paste it. Where is my, okay. So you can copy and paste it in your cell to make it easier so you don't have to retype the whole thing. So you can change this, probably, like if you want to have 5 to 7 or whatever, run it again. So it will create an array like that, okay? So with that, you can create so many things. You can create matrix multiplication, inverse, finding eigenvalues, and so on and so forth. So those are for those who are involved in more numerical kind of operation in Python. We're not going to do that, but it's just to show you that you can do this in Python. Okay. So now what we're going to do, we're going to have more elaborate again. Here's an example again. Let's do this. Let's do some kind of statistic. Import numpy as np. The reason we want to have np, the imported as np, the reason we want to do that, we don't have to use as np. It's just to make typing it simpler. So if you call the function here, for example, in the above example, it says a equal to np.array. So instead of typing numpy, we just call it np. Okay? It's a short of numpy. Just to save a few keystrokes, and it's actually useful. Now let's start. For example, I want to create a variable called berat or weight. Now let's create a numpy random, and I want to have a random integer, random integer. Let's create the integer from let's see low safe. This is for example, I want to create a list of wait, okay. Okay, let's just do this. Okay, let's just do this. So I want to create a random numbers. The size is 10. From the low is 50, the high is 100. So if I run it, it will generate a sequence of numbers, 10 numbers, and it will generate it between 50 to 100. Just copy this one again. So I can say, if you run it again, it's going to give me a different kind of number. So you run again, say it's 55, 79, whatever, then you run it again, it will give you 10 different numbers. If I want to say the size create 50, it will give me 50 numbers. Okay. If I want to create like 100, I can just change this. The size is 100, and it will give me random numbers between 50 to 100 numbers. Okay. You can also say, make it 300, for example. Yeah, that's also possible. So, okay. Play with it. Okay. Let me know if you already have enough. Give me your thumb. So we can continue, move on. Is it good? Okay, too fast? Is it okay? Okay, yeah. Okay. So this is to show you how easy it is to create, to generate programming in Python. Now, let's suppose we want to save this one into a file, for example, right? I can save it in a file, say, let's just save it in a file. Let's do this, np numpy save text into a text file. and I call it, say, berat.csv, okay? That's the name of the file name. What is the variable that we want to save? We will call it berat. And then the format fmt is %i. Okay, let's. What does this format means? Okay, so I want to save this into a file called berat.csv. The variable that I want to save is berat, yeah, this variable, and the format is %i. %i means integer. Later on, we'll save it in. We'll save an example in real number. So if I run it, it will generate 300 numbers, right? And then it will also save these 300 numbers in a file. So just copy this one again. Just give you this so you can run it also in your session, yeah, here. Now, where does it save this file? Well, if you look into the left side, there's this folder icon. If you click on it, then you'll see that the file is actually saved in your Google Colab session. So there's this file, berat. If you want to see the content, so it will have like 56, 72, yeah. If you double click it, and then you'll see on the right side, it will say 56, 72, 72, 69, 77, just like this, right? Like this. One number for each row. So you have 300 entries. The first line, it is 56. If we double click it, it will assume that the first line is actually the heading of the cell, right? If you have like a spreadsheet. But since we don't have the heading, it will take the 56 as the heading of the cell. Okay. You can download this if you click on these 3 dots. If you click it, there's a menu. You see a pull down menu. You can have like a download, rename, delete, and so on. If you download it, it will be downloaded into your computer. So you can open it later on with your spreadsheet. You can open with Excel, for example. And then you can view this file, okay? Ada pertanyaan, questions? Belum ada? Is it okay? So this is if you want to do some kind of simulation. Yes, Julia.
Sorry, sir, for me is a little bit too fast. How to make it to download again? I copy and then press select cell, and then everything gets copied. I don't know.
What do you mean? You want to download?
Yeah. Like,
okay. Okay. You select this folder icon on the left.
And
Click
then
select.
take the
Right. And then you see the file name berat.csv, and then there's a 3 dots here, right? And then you click on 3 dots, and then there's a download.
Okay, sir, thank you.
Okay, so if you download, it will get downloaded into your computer, in your download directory. Okay, so you can open it using your spreadsheet, Excel, for example. Okay. Now, to me, these numbers, for me, it's difficult to comprehend these numbers. I want to see this kind of the statistic, yeah. How many numbers? How many 50 numbers, 60 numbers? Oh, okay. Now let's plot this. Let's create a graph. Now the second module or the second library that we want to use is matplotlib. Import matplotlib pyplot_splt. Okay, so similar to NumPy. Sorry, I have a problem with I'm coughing. I have, hang on a second. Let me just drink my obat batuk first. Okay, wait. Let me have my obat batuk first. Okay, so I have my obat batuk. Okay, so I want to plot this. I can use matplotlib to plot it. What is matplotlib? Okay, let's just search matplotlib. So matplotlib is a visualization library for Python. It can visualize your data in all kinds of things. Here's is say examples, okay, or I'll just keep plot type. If you click on the plot type, it will show you all kind of plots that we can do. You can do plot XY, scattered, bar, stem, fill in between, stack plot, stairs. It can also do statistical histogram, violin plot, okay, histogram 2D, hex bin, pie chart, grid data. You can have some kind of contour. Okay, this one irregular gridded data. You can also even plot a 3D plots. Okay, so it's also possible with Matplotlib. If you want to find the example, for example, if you want to see this, you can double or click this, and it will give you an example. This is the Python code that generate data like this. So if you print it, then it will create a plot like that. So there are examples to do that. You can see all kinds of examples. Okay, see, you can have different kind of examples. Two charts, right? More complex plots, right? This is also possible with Matplotlib. Now let's do this in our example. We have this data. I want to plot it some kind in histogram. Okay, so I can do this plot histogram. I want to plot berat, for example, right? This is the default. Okay, if I do this and then I can plt show. If I do this and if I run it, it will create more like plot something like this. Let me just copy this one and give it to you. Okay, as an example, okay? So you can copy and paste that one. Okay, now what it does, this is will plot between 50 to 100. It will plot how many entries. For example, this one is 50, between 50 to 55. There are about 26 entries. There are 26 entries. Wait, let me just. Okay, there are like maybe 26 entries. So I want it, say for example, more detail. Okay, let's just do this instead of berat. I can say binge. I can tell it the range is between 50 to 100. It's between 50, say 50 to 101, for example, right? And I can print again, so it will print like that. Okay, in more detail. And if I don't like the color, I can put let's change the color here. Color, say red. Let's just do this. So it will print this. Let's just change it to green, for example. Run it again, it will print as green. Or sky blue, for example. Okay, so this is an example. Now, I can also say, I don't know what the x-axis is. Okay, let's have something with x-axis. Okay, so let's do this. Plot x label, probably say weight. Okay, weight. And then plot the y label, number of people. Okay, let's just run it again. So it will have this number of people in the y-axis, and then the x-axis is weight, and then you can have that one. Okay, so this is an example of how you plot the data in Python. Let me just copy this one again, so you can play with it in your code. So this one will work because in previous cell we already have the berat variable, right? It will generate the random variable, and then it will generate it, and it will put it into a file. And now here we plot that berat variable, okay, into the histogram. Okay. Give me a thumbs if it's okay. So we can move on to the next example. Maybe if you're still playing with it, that's okay. Good. Okay. Now, okay, the others already okay. Only one of you said okay. The others are still playing, or you need more examples? Ada pertanyaan kah? Is it okay? Give me your thumb if it's okay. Only one person already give me thumb. Give me more thumbs. Okay. Okay, ya.
Okay, sir.
Okay, now let's move on. Now let's take a different approach. So, suppose no, yeah. Let's see. Let's do this. Let's create wait, where's my let's create and this I don't want that one. Let me just remove. Okay. Okay, let's add okay, now let's take another approach. Suppose you have already a CSV file somewhere. Let's start with this. Suppose I have this Berat CSV and I want to print out. I want to read it and display the graph. I don't want to generate it, but I just want to read it. Okay. So again, I can wait. What does it do? Okay. I think I'm doing something wrong here. Okay, now let's start with from again. NumPy. Sorry, I actually usually we import NumPy as NP, yeah, but now we are going to import another library. Import generate from text. Okay, this is that what we want to do. We want to have data is equal gen from txt Berat CSV. Okay, I read that one. And then I can, let me just print Berat first, print data. So let me just copy this one. Again, I'll give it to you through the chat section. Okay. So if I run this, it will read from Berat CSV file and it will read the data one by one. Remember, the data contains like 56, 72, 72, and so on, right? So it will read it from that one. And if I want to display this, I just put a pound sign so it doesn't do anything. Now, let me copy the same code again. But this one, I want to print data, right? Okay, let's do print, let's do data here, right? Sub for Berat. So if I run it again, then it will give me the same diagram. But this is basically you generate this data from a file called berat.csv. Let me just copy this one again, give it to you again, okay? So we can have a file from your spreadsheet. For example, you have an Excel file and you want to view your Excel file and you want to see the graph of your Excel file. This is what you do. You open the Excel file, assuming the Excel file is exported into CSV, right? So we read it and then we'll plot the diagram for you. So you can generate data, save it into a CSV file. Now for this particular case, you have a CSV file. I want to get the data. Okay, so it's the other way around. Now you can read and write CSV file. Ada pertanyaan? Before we move on to naik lagi, more difficult. Give me thumbs if it's already okay. Give me thumbs down if you're still confused. Let me know which part so we can renew it again. Okay. Yeah. Okay, now let me continue, okay? So now we already have this. Now Let's do another plot, but this one is a bit different again. Okay, let's have this again. Now, let's start with import matplot lib pyplot pyplot splt. Okay. Now, assuming I have some kind of variable called x1, it is a list. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. We have 9 data, for example, and then I have y1, which is let's see, it has also 9 data. I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, for example, right? Now I have this x and y. I want to plot it against each other. Okay, so I can plot it, say, plt plot x1s against y1. Okay, now I can see plt show. I can do this. Okay, let's just run this. Sorry, not plot, plt. Okay. Huh? Oh, sorry, plt, this one is plot. That one is plt. Okay, I want to have like a plot x and y. So this is what we have. Okay, let me just copy this one to you. So this is basically I have x and y. So x is 1, y is 5, x is 2, y is 2. Okay, x is 3, 1 is 5, and y is 5, yeah, and so on and so forth. So I have this. If I want to have, say, I don't like the color. Let's see the color. This one is, sometimes we call it color. Sometimes it's okay if I can say color is equal red, for example, right? Let's do this. Okay, so it will become. What if I want to have 2 variables? Okay, let's say I have another one. Say x2. Okay, maybe let's start this one from 2. Yeah, 2, 3, 4, 5, 6, 7, for example. Only 7 data, 5 or 6 data. Okay, and then y2 I have maybe let's pretend like, I don't know, 7. Oh, wait, 7, 6, 1, something like this. Okay. Now I want to plot also the x, this one. Okay, but I want to plot it different. Okay, let's just plot stuff. But I want to plot it scattered plot. Scatter x2 by y2. Okay, let's just run it. See, you can see that the first one is plot like a continuous line, right? Not continuous, but basically line. And then the other one is scattered, which is basically only dot, 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 dot. Now I can also create a label. Say, for example, let's create this one is, let's edit this one. Let's edit a label. So I'll call it product 1. And then this one, let's say label is called product 2. Okay. If I run it again, then it will have, okay, I want to show the legend here. Okay. PLT legend, for example, right? If you do this, if you run it again, so you can see this, there's a, like the red one is product 1, the dot is product. Okay, let me just copy this one again. So this is an example of how you play with matplotlib. Adakah pertanyaan? Silahkan. Oh, let's just maybe let's just plot legend, and then probably let's say plot x label. Maybe this is, let's call it time. And then the y label, plt y label, number of product, for example. Let's run it again. So this time we have like this, right? Time. Or if you want to have this one also a plot, like plot again, okay, it's also possible. So you have, like this. Adakah pertanyaan? Just do this, copy again. This is an example of very simple graphs with small data. You can have complicated data, just like examples in Matplotlib, right? Just like these examples, right? You can have all kinds of, interesting plot. For example, like plot like this, you can do that also in Matplotlib. Give me thumbs if it's already okay, thumbs up okay, thumbs down not okay. Oke. Adakah pertanyaan? Now, after this we'll do two statistics. More statistics. Ada pertanyaan? Is there a question? It's going to be a bit more difficult, just slightly. Give me thumbs if it's okay. Thumbs down if it's not okay. Only one
Okay,
person,
sir.
but only one person, only you. Okay, 2 persons. How about the rest of you? Are still confused or let me know because it's going to be more difficult. Oke ya. Yang lain bagaimana? Bingung atau got confused or give me some kind of
I think
feedback?
too fast, Pak.
Too fast. Which part let me know to, when I want to, let me know to slow down, for example, because the way I study is I learn everything now. I don't put it to say, I'll learn it later on or I'll study it by myself, just learn it right now. If you have questions, feel free to ask question, stop me, and then we can run it again. Okay, because it's going to be more difficult and more difficult. Ada lagi? Sampai di mana, Dina?
I just have a question, Pak.
Yeah.
Why my collab after I try graphic, after that it mentioned that collab paid product, cancel contract here. So like not having the code for writing again. I don't know why.
Can you show me the screen? Is it possible? So I can debug it. Google Colab also has a say. Okay. Wait. I'll allow it. Okay. Okay. Do it again because I have not allowed before. Okay. Let's wait. Okay. Go up again.
Yeah, and then after that it is like collab paid product. So
Okay.
I cannot do it again.
Okay. Go up again. Up again. Oh,
I make a new screen actually because
okay.
yeah, for the lesson number 2, and then it's collab pet product. So I open another one, lesson 2A, but it's still like that, collab pet again. I don't know. And when I click, it mentioned it need to pay.
Yeah. In my opinion, close some of the Google Colabs, most of the Google Colabs, because probably it says you have too many Google Colabs, you have to pay for more if you have to have Google Colabs. So if you close it, right, don't worry because files usually files are safe in your Google Drive directory, so your files are still there. Close all of them. Just open 1 or 2.
Okay, Pak. Yeah, noted. Thank you.
Okay. Now, Google Colab actually has a restriction also. If you are running simulation that takes a while, sometimes you have lots of calculation. For example, my students did research in AI, so they're using Google Colab to run the training session. I don't know how many hours, and it says, "Oh, okay, I cannot do anymore." Like you have to pay if you want to do this because you are consuming the resources from Google. So they have a commercial version of it, the same thing, but it has more time, it has more kind of resources. Okay. Oke ya, kalau ada pertanyaan lagi silahkan ya. Now, let's create a new session, and this one we want to have linear regression. Okay. Let's start with import NumPy as MP. Okay, as MP. Okay. Now, assuming I want to create a like a line. Okay. Here is an equation of line. Y is equal, say, ax plus b, for example, right? I have a straight line. Y is a function of x. The what do you call it? The slope of the x. So the line it depends on a, and then the b is where the line crosses 0. Okay. So this is what I want to do. Now let's start. Okay, let's say suppose a. Let me just say suppose a is 0.25 and b is equal 0.75. Suppose this is just an example. Okay. Now let's create a number of points, number of points, right? Orange number of points. Say I want to create 300 points. Okay. Now let's create an empty list first, because I want to create 100 numbers. Let's say create X point. This is a list. Let's create it an empty first. Okay, an empty list. And then the same thing is Y point. This is a variable. Variable is empty, still empty. Okay. This is a list of numbers, but now let's initialize it with empty. Okay. Now let's generate 100 numbers from, for I in range number of points. Okay. So I'm going to do look for this 100 times number of points, right? Let's say X, let's generate X is random and P random. Now, remember earlier I have a random integer, right? But now I want to have a different distribution. It's more like a normal distribution. Normal between 0 to 0.0, right? To 0.4. For example, I want to have X between this. Okay? 100 times. Now, Y is equal A multiplied by X, right? According to our what do you call it? Rumus ya. Okay. Y is equal A multiplied by X plus B. Okay. So this is what I want to do. Okay. And then I want to add this X into the list. X point. Okay. Append X. And then put the Y into Y point. Append. Okay. Now, if I do this, like let's just make it 10, not 100, okay? To make it clear. Okay, so now let's print say X point. If I run this, it will just print like 10 numbers of X. And then if I do the same thing, print Y point. So this is basically print like 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The same thing, Y. Okay. So this is basically this is to show that we generate 10 numbers. Okay. And those numbers, we're going to put it into this list. Okay. X point contains 10 numbers. Y point contains 10 numbers. Okay. Now, I don't want to print them. Okay. So basically, I have this 10 numbers. Okay. Now, let's see the data, what it looks like. Okay, let's do this. Let's see. Again, import matplotlib, plotlib pyplot splt, matplotlib pyplot splt. Okay, and then let's do plot scatter. Okay, and then plt scattered between, I want to between Y point, X point, and Y point. Okay, and then I want to show it, PLT show. Let me run it first and then copy this code to you. Okay. Oh, sorry, PLT show. Okay, so let's do this. Let's do this and copy it to you first. Wait, where is my chat? Okay. Okay. So what I'm doing here, I created 10 points. Okay. So this is the X, and then that's why the Y. If you look, this is kind of the line that we want to create, right? The dots are the point. So we have like 10 dots. Let's generate more dots. Instead of 10, let's generate 100. Let's run it again. So it will generate like 100. Okay. So this one is this line, right? When we plot it, we can plot it as, I think. Let's just do this. Can I do this? Okay, no, I can't. Okay. Wait. Okay, let's just do this. Okay. Let's run it again. Okay, now I can create 300 points. It is actually make it, like denser. Okay. So this is the line that we use, right? The slope is 0.25, and the place where it hits 0 is 0. Wait. This is if x is equal 0, b is 0.75. Okay, if x is 0, b is 0.75, somewhere here. Okay, now this is kind of a very perfect line. Let's add some noise into this. Let's add some noise into the y. Okay. So instead of x multiplied by a plus b, let's add some random number. Okay, add. Okay, np. Okay, let's create a random. Make it. So the y, we want to have some kind of noise. So if we run it, see, you can see like there is a noise. It's not in the form of straight line. So there are noise because the y is kind of kind of squish, not squish, moved a bit with the noise. The noise is 0.01. Let's just add 0.05, for example. You can see like now the noise makes the data not in a straight line anymore. Let's create more data. I can create more data. Let's do this 500, for example. See, something like that. Let's just create it 3, and then let's just do this. Okay, let me just copy the code for you so you can play with it. Okay. Okay. So again, let me explain it again. So we want to create a line. Okay, this is the formula of a line. Y is equal a multiplied by x plus b. So that's the line. Okay. So the a is 0.25, the b is 0.7. You can play with it. You can change it if you want. And then the number of points, how many points we want to create, we can create, say, 300 points. Okay. Let's initialize an empty list for the x and y. Let's do this 300 times. Okay, whatever number of points you want to use, because it says here for I in the range of number of points, which is whatever value we put here, right? We're going to replace this variable with that number. X, let's generate x random between 0 to 0.4. So if you look, it's between 0 to 0.4 basically, to the left, to the right. Okay. And then y is according to this formula. Y is a multiplied by x plus b. Okay, a plus b. But now we have some kind of random, okay, noise. So we generate x, we generate y, and then we add it into this list. Okay, we append into this list the x and then the y. So now we have 300 points, x, y, x, y, x, y, x, y, x, y, x, y, right? 300 points. I want to see the data. So this is how we do it. We create a scatter plot. So something like this. Okay. Adakah pertanyaan? Aduh, masih batuk. Ada pertanyaan? Kalau enggak, kasih jempol, give me a thumbs up if it's okay, thumbs down if it's not okay. So this is basically, we're creating like a straight line, okay? Now, what we can do also, we can also save with, we can also save this, let's save this one. Add another line here, save, just like before, np, save txt, let's call it line.csv. Now, what do I want to, what do we want to save? We want to save xy, 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 but we want to have like xy, and then the next line xy, and then the next line xy, right? How do we do that? So apparently there are ways to do that in Python. All you have to do is do this. We want to, we want to stack, what do you call it? They call it stack. How do I, Pak Budi, how do you know the command of this? I'm looking at examples, actually. I'm looking at examples. So this is what I'm doing. Save the data into a file called line.csv. The format, what I want to create is x and y, but I want to create xy, xy. So this is np column stack. So we create a column stack, xy, 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 xy. So this is what I want to do, x and y. Now the format, remember the Euler format is %i. %i is integer. %.5, f it means floating point. .5 is 5 digits behind the dots. 5 angka di belakang koma in bahasa Indonesia. The delimiter is comma. So if I run this, okay, let me just copy this line so you can put it in your code. Okay. If I run this, okay, it will generate the same plots, but it will also save a file here. If you click on the folder here, you see that there's a file called line.csv. So we are saving this xy into a file called line.csv. If you double click this line.csv, on the right side you can see that this is the content of the line.csv. xy, 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 xy. So we have 300 entries, xy, xy, xy. You can also download this line.csv into your computer, and then you can open it into your Excel, for example. You can see like there are 2 columns, xy, xy, xy. Okay, something like this. Okay, ada pertanyaan? So this is generating a collection of data in forms of lines. Adakah pertanyaan? Thumbs up if it's okay. Thumbs down if you are still confused. Adakah pertanyaan? If I give you a quiz, will you remember this? Okay, yeah. Only one person says okay. The rest of you still confused? Okay, 2. Okay, good, 2. Okay. Okay, now. Okay, 3. Okay, now. Let's forget about that. Now let's do a different thing. Okay, suppose I have that CSV file. Now the story is different. I have this line.csv file, maybe generated with a program, maybe I take it from my simulation, maybe it's from a plant or whatever, right? I have that CSV file. How do I read that CSV file? And then how do I plot it? Okay, so this is what I do. Again, I import NumPy as NP, okay, as you saw. Now let me import. Let's call it the variable. Let's call it my CSV, for example. Now I can call it np generate from text. Okay, generate from text. Okay, generate from text. The name of the file is line.csv. Okay, okay, okay. And then let me just print it first. Okay, if I run it, so it will read the line.csv. Okay, and it will read from my line.csv, and it will read into X, Y, X, Y, X, Y, X, Y, right? If you don't believe me, let's open this. Okay. So you can see that the first line is 0.65, like this one, right? So that's the first line. This is the second line. This is just the way it is formatted, like it's e to the power of -1, it's 0 point basically, okay, 0.90. And if you can see, there are 5 digits, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. If you see 9 dot, there are 5 digits here. Okay. Okay. So ada 5 angka di belakang koma, kind of. Okay. I don't want to print it, but I want to see it. See, I have this line CSV and I want to see it. Okay. When I print it, I can see this is X, Y, X, Y, and Y. Okay. Now I have X, Y, X, Y, X, Y, but I want to read it and I want to create a list from it. So I have X point, comma, Y point, okay, equal. Let's get from my CSV. Okay, how do we do it? Let's say from my CSV, I want to get it and I want to, we call it transpose. Okay, now, so with this, let me just print. Okay, print XP, comma, YP. Okay, let's do this. So if you can see, it will print X, Y, X, Y, X, Y, X, Y. Okay, but not not in a beautiful way. Okay, so basically I already have X and Y. I can print it on the screen. I can also plot it if I want to. Okay, okay. So let's just run it again. Okay, so I have this X and Y. Now this is basically X and Y in this. Now the question is, what is it? It may be like a line, right? See, if I run it, okay. So this looks like a line, but what is the function of this line? I want to find out the A and B. Okay. So if I have that data, what is the A and B? What is the A and B? Well, I can write a program for that. But in Python, oh, we don't need to write a program. All we have to do is we again call a library called SciPy. SciPy is a scientific library, and I import a library called statistic. So I import stats. Now with the stats, I can calculate the linear regression, the slope. Okay, there's a slope, intercept, the R value, P value, standard error of linear regression. So I'm calling this linear regression function from the stats module using X and YP. So it will have this slope and intercept. The slope is actually the A, the intercept is B. If you don't believe me, if I run this, okay, so it will have the A is 0.245 whatever, and B is 0.75 whatever. Remember, in our example, A is 0.25, B is 0.75. Okay, let me just copy this one and give it to you so you can run it and play with it. Now, what I'm going to do is, suppose let's generate a new data, right? I don't want to. Let's generate a new data. Instead of 0.25, let's call it this one is 0.33, and then the B is 0.88, for example, right? Just run it again. So it will generate this line CSV, okay, with a new point, okay. Now let's run this one again, okay. So if you can see, it will read the line CSV and it will try to determine the slope and the intercept. If you can see that the variable, the A is 0.33 something something, and the B is 0.879, which is 0.88, right? So this is close to our initial value. So this is what we call a linear regression. Given a set of data, and we see that the data may be in the form of a straight line, what is the slope and what is the intercept value? So using this one line, we can get that. In the old days, I have to write a code for this. I have to write a program to do this, calculate that. Now with Python, with one line, I can do it. So if I can, just make it very compact. So this is what I do. I can write it in a very compact, like how many lines? 1, 2, 3, 4, 5, 5 lines. I can have this kind of linear regression. Ada pertanyaan? Is there a question? And then after this, we do one more time, and then that's it. Getting confused? Thumbs up, thumbs down, confused? Confused? If you are confused, give me one of those try icon. Wait, where is my, for some reason, I don't have this. Let me just do this again. I don't have my, where is my, why don't I have, reaction? Why don't I have the reaction, huh? Let me just stop again. Wait. Stop, share again. How come I don't have the reaction? I don't know why I don't have the reaction. I want to have my reaction. Give me a reaction. Thumb up, thumbs down, confused. What is that reaction? Pusing? Kok nggak ada reaction ya? So this is basically you're given data and then you have to solve this mathematical equation. In the old days, you have to write programs for it. But with Python, with just one line, it will solve the problem. If you know you have a problem that you have to solve it with linear regression, this is how you do it. Okay. So linear regression, remember when we do data science, we have your wisdom in the business process or the business idea or the business domain. And then you have the statistic. This one is from statistic linear regression. And then this one, the other side is the computer science or the hacking or the hacker. So right now what we are doing is we are trying to combine them together. Okay. Now, the last one. Give me, okay, no, the last one. Now, the last one is before I'm going to explain that one, let's watch a video first. This is what we call k-means clustering. Let me just search start quest, I think. Start quest k-means clustering. Okay, I think this is okay. Okay, let's watch a video, okay?
Hi, my name is Dot Lung. I'm a global social media strategist working with companies.
I have advertising first. Okay.
StatQuest.
It's kind of weird.
StatQuest. Hello, I'm Josh Starmer, and welcome to StatQuest. Today we're going to be talking about k-means clustering. We're going to learn how to cluster samples that can be put on a line, on an XY graph, and even on a heat map. And lastly, we'll also talk about how to pick the best value for k. Imagine you had some data that you could plot on a line, and you knew you needed to put it into 3 clusters. Maybe they are measurements from 3 different types of tumors or other cell types. In this case, the data make 3 relatively obvious clusters. But rather than rely on our eye, let's see if we can get a computer to identify the same 3 clusters. To do this, we'll use k-means clustering. We'll start with raw data that we haven't yet clustered. Step 1, select the number of clusters you want to identify in your data. This is the k in k-means clustering. In this case, we'll select k equals 3. That is to say, we want to identify 3 clusters. There is a fancier way to select.
Sir, where is the voice? There is no sound.
Oh, okay. Okay, hang on. Wait. Let's start again then. Let's start again. Let's start again.
It's kind of yellow.
Okay, let's start again. Wait. Let's start again. Okay, Shershan. Oh, let's start again. Let's start again.
StatQuest. StatQuest.
Okay, so now there's a sound, right?
StatQuest.
Okay.
StatQuest. Hello, I'm Josh Starmer, and welcome to StatQuest. Today we're going to be talking about k-means clustering. We're going to learn how to cluster samples that can be put on a line, on an XY graph, and even on a heat map. And lastly, we'll also talk about how to pick the best value for k. Imagine you had some data that you could plot on a line, and you knew you needed to put it into 3 clusters. Maybe they are measurements from 3 different types of tumors or other cell types. In this case, the data make 3 relatively obvious clusters. But rather than rely on our eye, let's see if we can get a computer to identify the same 3 clusters. To do this, we'll use k-means clustering. We'll start with raw data that we haven't yet clustered. Step 1. Select the number of clusters you want to identify in your data. This is the k in k-means clustering. In this case, we'll select k equals 3. That is to say, we want to identify 3 clusters. There is a fancier way to select a value for k, but we'll talk about that later. Step 2. Randomly select 3 distinct data points. These are the initial clusters. Step 3. Measure the distance between the first point and the 3 initial clusters. This is the distance from the first point to the blue cluster. This is the distance from the first point to the green cluster. And this is the distance from the first point to the orange cluster. Well, it's kind of yellow, but we'll just call it orange for now. Step 4. Assign the first point to the nearest cluster. In this case, the nearest cluster is the blue cluster. Now we do the same thing for the next point. We measure the distances, and then assign the point to the nearest cluster. Now we figure out which cluster the third point belongs to. We measure the distances, and then assign the point to the nearest cluster. The rest of these points are closest to the orange cluster, so they'll go in that one too. Now that all the points are in clusters, we go on to Step 5. Calculate the mean of each cluster. Then we repeat what we just did, measure and cluster, using the mean values. Since the clustering did not change at all during the last iteration, we're done. Bam! The k-means clustering is pretty terrible compared to what we did by eye. We can assess the quality of the clustering by adding up the variation within each cluster. Here's the total variation within the clusters. Since k-means clustering can't see the best clustering, its only option is to keep track of these clusters and their total variance and do the whole thing over again with different starting points. So here we are again, back at the beginning. K-means clustering picks 3 initial clusters, and then clusters all the remaining points, calculates the mean of each cluster, and then reclusters based on the new means. It repeats until the clusters no longer change. Boop, 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 boop. Now that the data are clustered, we sum the variation within each cluster. And then we do it all again. At this point, k-means clustering knows that the second clustering is the best clustering so far, but it doesn't know if it's the best overall, so it will do a few more clusters. It does as many as you tell it to do, and then come back and return that one if it is still the best. Question: how do you figure out what value to use for k? With this data, it's obvious that we should set k to 3, but other times it is not so clear. One way to decide is to just try different values for k.
Advertising. Okay.
We'll start with k equals 1. K equals 1 is the worst case scenario. We can quantify its badness with the total variation. Now try k equals 2. K equals 2 is better, and we can quantify how much better by comparing the total variation within the two clusters to k equals 1. Now try k equals 3. K equals 3 is even better. We can quantify how much better by comparing the total variation within the three clusters to k equals 2. Now try k equals 4. The total variation within each cluster is less than when k equals 3. Each time we add a new cluster, the total variation within each cluster is smaller than before. And when there is only 1 point per cluster, the variation equals 0. However, if we plot the reduction in variance per value for k, there is a huge reduction in variation with k equals 3, but after that, the variation doesn't go down as quickly. This is called an elbow plot, and you can pick k by finding the elbow in the plot. Question: how is k-means clustering different from hierarchical clustering? K-means clustering specifically tries to put the data into the number of clusters you tell it to. Hierarchical clustering just tells you, pairwise, what two things are most similar. Question: what if our data isn't plotted on a number line? Just like before, you pick 3 random points. And we use the Euclidean distance. In 2 dimensions, the Euclidean distance is the same thing as the Pythagorean theorem. Then, just like before, we assign the point to the nearest cluster. And just like before, we then calculate the center of each cluster and recluster. Bam! Although this looks good, the computer doesn't know that until it does the clustering a few more times. Question: what if my data is a heat map? Well, if we just have 2 samples, we can rename them X and Y. And we can then plot the data in an XY graph. Then we can cluster just like before. Note, we don't actually need to plot the data in order to cluster it. We just need to calculate the distances between things. When we have 2 samples, or 2 axes, the Euclidean distance is the square root of x squared plus y squared. When we have 3 samples, or 3 axes, the Euclidean distance is the square root of x squared plus y squared plus z squared. And when we have 4 samples, or 4 axes, the Euclidean distance is the square root of x squared plus y squared plus z squared plus a squared, etc., etc., etc. Hooray! We've made it to the end of another exciting StatQuest. If you like this StatQuest and want to see more, please subscribe. And
Okay, now so that's that. With that in mind, let's let's go back to our examples. Okay, now where is my share button again? Okay, here is my share button. Where is my okay, let's go back to our example. Now let's try the k-means clustering. Okay, so suppose I have a file called cluster.csv. Let me give you the file itself. Okay, wait. I have to send you the file. Okay, where is my file? Wait. Chat. Okay, send the file. Let me say file. The file it's called cluster. I think it's called cluster.csv. Okay, So I have a file, and I have sent you to the chat. Okay, so you have this cluster CSV file. Let me upload it also to my browser here. Hey, wait. I have my. So okay, you have that cluster file. Okay, now let me upload my file cluster CSV. Okay, so again the same thing here. I can upload my CSV file into my Google Colab session by clicking this. If you go to the folder here, right? Folder here. Okay, you can upload it here using the upload icon. If you click on upload, and then it will select. It will ask you to select the file, and I upload that file cluster.csv. Okay. So assuming I want to see what this cluster CSV looks like, if I double click it, and you can see that this is kind of, there are, I don't know how many numbers there. Okay, there are about 302 entries, right? 303 entries, right? So there are entries like this. Now I want to see how it looks like. Let's start by doing doing some kind of coding. Now let's import another library, and this one is called Pandas, one of the most important libraries in Python. Import. Let's start. Import Pandas SPD. Okay. Now let's read df. We call it data frame. Let's read PD using Panda. Read CSV. The name of the file is called cluster.csv. Okay, let's just read the cluster, the CSV, and then let's say header equal none, because we don't have the header in the first line, right? Okay, now let's just print it. Let's just print df, for example. If I run this, it will print. So it's just exactly like Excel, right? Remember, this is x, y, x, y. But you see that there are two columns. This is the first column, okay, and then the second column, and then there are 303 lines, right? So this is kind of more like a spreadsheet, like. Okay. Now let's rename the columns. Okay, let's rename the column. Let's rename the column, the first column. Let's rename it the F columns. Let's rename column. Let's rename the first column. Let's call it X, and then the second column, let's call it Y. Okay. So if you run it again, so you can see. Sorry. If F columns equal, is my equal. Okay. So you can see this is the X, this is the Y. Okay. Now I want to see. Okay. What it looks like. Okay, let me just copy this one first and then send it to you. Although you have to update you have to upload your cluster CSV first. Okay. Now I don't want to print it. I want to see it. Okay. So again, I want to use matplotlib to see it, right? So I import matplotlib pyplot splt. Okay, and then I want to plot it. Okay, hang on a second. df plot. The type is scattered. Kind. Scattered x and y show. Okay, let's just run it. See, you can see that the data actually, the x and y, there are three columns. There are three clusters. Maybe this is a data coming from your call center, for example. The X and Y is actually the geolocation of your caller. So you know that, oh, okay, my customers are in these three regions, for example. Okay, let me just copy this one again, and then give it to you. Wait. So I have these three clusters, right? We can see it with our own eyes, but the computer has to know how many clusters and what are the center of the cluster. So if we want, say, to open a restaurant close to this area or a store, I want to have like 3 stores here because I know that this is the customer, right? Now, how do I do this? I want to find the cluster. Remember, through the video, the start quest video, you have to write a program, right, that does that. Do this over and over again, create the cluster. But with Python, all we have to do is we take the library. Okay. So this is there is another library called sklearn. Sklearn, this is kind of a library, Python library, and we want to import k-means the library. Okay. The library, and then using that library, okay, so I can say k-means and cluster is equal 3. We have, and then we want to fit our data, the df. This is the df, the data that we read from that kind of. I'll just from this cluster that CSV. We said three clusters fit the df. Okay, now show me where is the centroids. Okay. The centroids are KM cluster centroid centers. Okay, and then print centroid. So if I run it, it will say, oh, okay, there are 3 centroids and these are the location, but I cannot see it. I don't want these numbers. I want to see it in this plot. Can you do that? Oh yeah, okay, it's possible. Okay, now let's see. Okay, now let's see. I don't want to plot scatter. Okay, let's just do this. Okay, let me just put comment here first. Okay, I don't want to plot it first. Okay. Okay, if I run it again, it will say, okay, there are 3 class. The centroid of this cluster. Let me just plot it with a nicer. Okay, let's just do this. Okay, let's plot the F and the Y. But now let's use different clusters to label the data set. Okay, let's just do this. If you can see, you can see now there are 3 clusters, and the red dots are the location of your centroids, and these different clusters are different clusters of your data. So you can see you have 3 clusters. Let me just copy this and give it to you. This is the complete program. Okay, wait. So this is an example of how you use statistics to, this is kind of the type of data science that we want to use. So now you are doing 3 things. You are the business person, you are also the statistics person or the math person, and you are also the programmer, the hacker person. So you write the code, you interpret the statistics, and you interpret it according to business. So this is an example where when you have a situation and you want to set up a location of your store. Suppose, for example, we have only we have budget only for 2 stores. Okay, let's just create the cluster only 2 instead of 3. Okay, so if I want to have 2 stores, okay, these are the most obvious location. One is here, and then the other one is there. Okay. If I have more money, if I have say 4 stores, where should I put the store? So 1 here, 2, 3, 4. If I run it again, it may have different results. Okay, so these are the. If I have more money, I have a 5. If I want to open 5 stores, for example, so I have 5 clusters: 1, 2, 3, 4, 5. So you can do a what if situation using this kind of programming style. Okay, let's go back to 3. Okay, so now let's go back to this. So these are your clusters, and this is the end of statistic for tonight. And then we can also, can I read not numbers in my data set? Can I read say also text file? Oh yeah, it's possible. This one you don't have to worry, but let me just do again now. Let's see if I have, say, here's an example. I want to upload, let's just upload another file. Let's see, plat nomor CSV. Okay, so suppose I have plat nomor, which is like this. This is the plat nomor, right? The license plate. I have 5. This is the license plate, the owner, the maker, the model. Ini D 1 2 3 4 1 2 3 XYZ, owner Budi, the maker Ferrari, the model F1. And then this one B 11444 AR. If you read it, it's PR. Dudung Toyota Corolla. And this one is D454R, which is dasar. Fulan Tesla. Ini daging ya, ini aing. So these are license plate, right? In a file, a CSV file. For example, this was generated in your license plate recognition or whatever. Can I read it? Oh yeah, obviously you can. You can also you can do simply by using using pandas, read plat nomor CSV and print it. So this is you read CSV file as simple as this, just one line, and then you can print it. So this is more like a reading spreadsheet Excel in your Python. You can sort it based on whatever you like, right? For example, I want to have sorted by maker. Okay, let's do this. Okay, let's sort it by maker. So you can have like me. So this one is sorted by maker. Okay. What if I want? What if I want? What I want to rearrange the column? Okay, you can do that also. You can rearrange the column. You sort it by license plate, the maker, and so on and so on. So you can do all kinds of things in Python. So that's that. That is what I'm going to share for tonight. Adakah pertanyaan, questions before we close the class tonight? Mulai confusing ya. I hope this is kind of the end of introduction to Python. I am doing it very quick. You don't have to become a Python programmer. That's not what I intend to do. So basically, this is just to to create an introduction to you how to program in Python, and then to show you what Python can do. Give you examples of Python modules, very simple Python modules, and what it can do for you, and give you examples of what we can do with Python. Adakah pertanyaan sebelum kita close tonight? Is there a question before we close the class tonight? Silahkan kalau ada pertanyaan.